Well, welcome to this masterclass. Don't know about a master, but it's a class. But due to popular demand, my limited knowledge on astrophotography with the subject of solar imaging has been requested. So here we are this evening trying to see if any of you know less than I do. So hopefully that might be the case, but I'm going to put a presentation up in a moment, share my screen so you can get an idea of what we can try and achieve together. And there'll be a Q&A at the end of this part to get any information that you didn't quite understand or I haven't passed on to you yet. And then after that, it's the fun business of acquisition of the image and how to process it. Okay, right. So what we were going to aim to do this evening is just go through the basic, what you have, what we can use to get through the process of acquiring an image, what is the best way to use the equipment safely, and what we can see through different types of filters, through the different wavelengths of using film or etalons or solar scopes, how to get hold of the image, how to get process the image to the desired effect that we all hope that we can achieve at the end of the time spent. So start with what we've got on the mount. Most of us have got one of these, German equatorial mount, although an old TAS mount will do because it's only going to be a short period of time to get hold of the image. So we can either use a German equatorial mount, or I've got a little tracking mount, which I use generally for my solar and lunar imaging. That's an Ioptron Skyguider Pro, which can have up to 5 kilograms weight with the counterweights on as well, just to help along. Or if you start getting really serious, then you can use a Skywatcher Solarquest, which is just for setting up and getting the sun into field of view by just pressing the on button. I'll go into the details of all that as we go on. So anyone with a telescope doesn't need to be too technically perfect. This is just something similar to what we've got at the Bath Astronomers, which is just a doublet. Doublets are good. It doesn't need to be too color compatible because most of the imaging we'll be doing is usually just with a mono camera. So if there's a bit of chromatic aberration, that's not going to worry too much, because by the time it gets filtered through, then you won't see anything of any problems with the optics at any stage during that time. This is the one that I've got, a William Optics GT71, which is a triplet, which I generally use with a times 2.5 power mate, which coupled with the camera sensor that I have, which is a 533 square format sensor, it fills the frame just nicely. So, but then if you get really carried away, you get one of these. Well, usually. This is a Coronado Solar Max made by Mead, which we mostly know to be in insolvency at the moment. Well, they've closed the offices down, so stocks of these, if they're in the UK, may rapidly disappear. There are a few that are on First Light Optics, and this happens to be one of them. And they are adjustable. This is a double etalon, where the etalon is at the front with the gold tuning knob on the front, and then just behind that you can see two tuning knobs behind that for the second etalon. And having two etalons will give you a much greater range of contrast. And when I saw one 2 months ago, I was absolutely blown away by the quality that you can achieve with this. And the beauty of this is it's absolutely instantaneous when you do the adjustments, unlike when you use a Quark, where you have to wait for it to tune after about 5 minutes of twiddling the knob. So this is a much more quicker way of doing things. Of course, you can always get a lunt. This will do as a daytime one as well. You can see the pressure tuning knob on the back. Everything from that assembly backwards will come off, and then you can just put an ordinary back on, so you can use it for nighttime as well. This is a single echelon. If you want another echelon to make it a double, you'd have to spend another £2,000 on top of the £7,000 that this already is. And then you need to spend an extra amount of money just to take the whole thing off to make it into a complete nighttime unit. So it's very expensive. But if you've got the dedication, then it's worth it, I guess. So obviously, just a warning, do not look at the sun other than using solar glasses or the special equipment that Simon or I have got when we're out during our outreach. It needs to have proper equipment to completely protect your eyes. And if you want to start off fairly quickly and cheaply, this is the simplest option, is to get some film. Daystar do two types of film. One which is a astro solar film, which is a 5.0 optical density, which is very safe to use, but you have to be aware that if there are any holes in it, you'll have to get a new sheet. It's like very, very thin baker foil, but it lets only about 0.05% of the sunlight through. The photo film is less opaque and is purely just for imaging. And that's completely unusable for visual. You'll just burn your eyeballs out with that, unfortunately. Okay. They are available in the UK. They are coming about A4 sheets, and they're about £25 for a sheet with instructions on how to cut it out and make a mask over the front of the tube to slot it over. If you want to go down the glass filter route, you can get them in various sizes like I've got here. The big one on the left, that's for my C11, and the other one is for the VT71. If you want to use a larger, say a 6-inch refractor, then you want to use energy rejection filter on the front of your telescope. Otherwise, you'll start cooking everything that passes down the tube to the quark or whatever you're going to be using to do the visual astronomy with. This is a tri-band which lets in the hydrogen alpha, calcium, and sodium light through. So very specialized piece of equipment and very expensive. If you want to ask me how much it is, I might tell you later. To help with the visual, there's a green filter which helps with the eye's natural ability to pick out better contrast in the green part of the spectrum. And this is from Altair, which will give you some increased surface details of the granulation and the umbra and penumbra on the surface. And if you want to get it a bit more tuned, this is up towards the blue ultraviolet end of the spectrum. And as you can see, it's a 2 nanometer bandwidth for that as well. So obviously just to be used with the Herschel Wedge as well, to make sure that you do not just use that purely on its own. This is the Herschel Wedge. This is made by Lunt, comes in a nice aluminium case. This is the 1¼ inch version. The Bath astronomers do have a 2-inch one as well, which is also useful for the optics up to a 6-inch refractor, which is very useful. The principles of the Herschel Wedge is a refractive piece of glass which lets most of the heat and some of the light through out of the back, which you can see on the image on the right, which does get a bit toasty on the back to help escape the heat that does build up in the wedge. But it's very useful, and there is a neutral density filter in the holder there, which the eyepiece or camera fits into. This is my own personal Quark, which is a chromosphere version. There is a prominence version, which is more tuned to the prominences, but most people will get the chromosphere version, which is a dual purpose and very much more useful. And I will go on to how that works shortly. This was loaned to me by Rob. Now this sees the spectrum in the calcium line, which is more towards the blue ultraviolet. And that gives some amazing surface details of the spots and the faculae all over it. You'll see some of the results from these various filters as well. Here we are. So a white light, the calcium, which I've just shown you with that adapter, which is in the purpley blue end, and then we've got the hydrogen alpha. The hydrogen alpha image was taken on a different day, but the white light and the calcium were taken both on Saturday. So it gives you some idea of what's going on. Although there is currently just coming around on the eastern limb a very large sunspot group coming round at the moment, and that one looks like it's a bit of a beastie to keep an eye out for the activity. So if that comes out as well as it might be predicted, that might get a lot of auroral activity from that as well if it produces a lot of energy towards the Earth. Right, okay, so here we have how we attach the equipment to the back of the telescope. So this is just for imaging in white light with the Herschel Wedge and a filter. So first of all, we put the Herschel Wedge in first. Then I put a paramate in, which will enlarge the image up to fill the sensor that I'm going to be putting onto. And then we put the camera onto the back there. Although there is a Altair filter holder there, which has got an IR UV cut then filter in there as well. Any questions so far?
Have you got an ERF at the other end?
This is only a 71mm refractor, and the Herschel Wedge is good up to about 100mm. After that, it gets a bit too much for it. Then you would have to put an ERF on the front. But as it is, it's perfectly fine. And I usually just put the image onto the sun, take a picture, and then move it away just to make sure anyway. So there's no damage to any of the equipment.
What's the knob on the back end of the camera?
Right. Now that is a cooling fan regulator on the back of that.
Right.
It's the camera that I've got is a Player One Saturn color camera, and because there's no other cooling system with it, you can put this on the back of it, and that just adjusts the speed of the fan, which helps cool it down a little bit. I haven't really used it very much because the weather that we've had hasn't been too great. But I have got a cooled mono camera with the same size sensor. So this is what I just generally use during the daytime to do any color imaging. Okay, so here's what we do to get the hydrogen alpha light train assemblage. So I put in a 2-inch 90-degree prism. Then the Quark. Then I put on a tilt plate adapter. I'll tell you about that in a moment. And then a mono camera. The mono camera is an ASI 174 mono, and as recommended by a lot of solar imagers. So that fills in quite nicely. And due to the magnification that the Quark has got, that's got a built-in 4.2 times Barlow. So consequently, I only get about half of the image with that sensor. So I have to do it in 2 goes and then stitch it together at the end to get the complete image all together. Now you may notice that there's a cable from a power bank into the Quark there, and it's amber at the moment. That's just to show you that it's receiving power, but it's not up to temperature. Each of the adjustments on that knob just above the light, when you tune it round, you need to give it a couple of minutes so it acclimatizes to the right frequency once that knob is tuned to a certain point. So once we've got it switched on, it's amber, and when it's up to temperature, it goes green. And each time you click that knob round, you have to wait for the amber light to come back on to go back to green to say you're ready to go again. Although you can use it before that goes green, but you won't get the maximum benefit of the tuning until that light is green. Okay, this is just to show you how I adjust it. It's just a simple matter of just turning the knob round, and when you've seen the differences between one end and the other, you get an idea of how the seeing compares with what the setting is on that knob to get the best out of it. Okay.
So it's just trial and error then, is it?
It's basically tuning it to what you think is best for yourself at the current time that you're imaging. So it can vary, although I usually generally keep it at one setting, which I find is generally good for most situations.
Right. Roger, sorry, is there an advantage of using this over like a standard Etalon in an HA scope? Well, I mean, do they give the same sort of appearance?
The Etalons on the Coronado and the Lentz, which are pressure tuned, they are instantaneous. This is the only drawback, although it is very handy to use it with any scope that you currently have in your possession. This will need warming up for about 5 minutes up to a certain point where you've got it tuned. And if it's not quite right, you have to adjust it, and you have to leave it for a few more minutes to get back to the adjustment that you've just moved it from. That's the only difference. I mean, the results between the Quark and a single Etalon are very compatible. But if you use a double Etalon, you're on another level because the contrast can be really staggeringly amazing. You have to physically see it for yourself to see what a difference the quality of the details are. But you do lose out on the brightness of the image. Simon does say it's dimmer. It is, but not considerably. And if you're imaging, that's easily to adjust. Right, so this is the Solarquest made by Skywatcher, purely just for solar imaging. Now, I'm just going to start the video. It's not been turned on yet, and I'll show you how quickly this will quickly find where it is. So I'll switch the volume down because you've got neighbors. So what it does, it levels itself out, and there's a GPS system in there. So it gets the date, the time, and the location of where you are, latitude and longitude. It will then calculate the height of where the sun will be in the sky, and then it rotates in a clockwise direction until it finds it. There is a sensor just on the other side of the telescope, which you will see as it rotates round. I don't usually have this far around from the sun, but as long as you're to the left of the sun, not too far away, then it won't take too long for the telescope to rotate to find it. As you can see, I've got the power bank strapped on with some elastic bands, which I generally have it mounted on the tray underneath, but I've just done this for quickness and stop the cable trailing round. As you can see, the little red knot is, and it's just coming round. It's just almost there. It'll just do a final tweak, and there we are. It's there. And if you look at the back of the, I know I shouldn't have the viewfinder on there, but you can see the projection of the sun on the rear of the element there. And if you looked at it through an eyepiece, it's there 9 times out of 10, pretty much in the middle, or you can just adjust it. There is a little joystick on the back there with the up, down, left, and right to just finely tune the position, but it will stay pretty much in tune with the sun from sunrise to sunset, and it's very easy to do. As long as you've got the spirit level on the top there fairly level, then you're good to go with that. So it's a very good, simple piece of equipment that you just sort of switch on and forget that you don't have to worry about trying to find it. And that was about £350 as far as I can remember. Have we got any questions so far?
What kind of weight will that take? Are you at the max
that will
there,
take up to 5 kilograms.
All right.
So not too bad. Any other questions about anything at the moment?